Hi, this is the second video on logarithms. On this video, we are going to talk about different types of logarithms, the most usual types of logarithms. Finally, we will see the different properties of logarithms. Okay, so for the first part, types of logarithms, we are going to talk about the common logarithm. Okay. Well, this is the logarithm that appears on your calculator. So look for this button on your calculator, okay? So this logarithm, it seems that it doesn't have any base, but yes, it actually has a base. So what is the base of this logarithm? The base is 10, okay? So you are going to, when you find this logarithm, only the logarithm of a number, remember that the base is 10, okay? You can write the 10, there's no problem, there's no any problem, but it usually appears without the base. But the base, remember that is 10, okay? Well, and in second place, we are going to talk about the natural logarithm. Okay, this is represented as ln, okay, on your calculator. And well, this is equal a logarithm with base the number e. The number e is also called exponential, sorry, with t, exponential number e. And this is an irrational number that is more or less 2.718, okay, etc. This is an important number that you are going to use many times, but more in next year. So, okay, so for this year, it's only important to know that this logarithm appears many times, and this logarithm has as base an irrational number, okay? So is all we have to know. Well, you will see that in some exercises you will have this logarithm, okay? So for example, if I want to calculate this, the logarithm of the exponential number to the power of 5, okay? Well, so this is the same as, well, the base, as you see, we don't see any base, but the base is this number, okay? So the exponential number is to the power of x, and it has to be equal to the number e to the power of 5. So obviously x is 5, okay? So x is 5, okay? Well, so after this, we are going to see some properties, okay? Some properties of logarithms. So the first property that we are going to see is when you have a logarithm, okay? So, and in the logarithm, there is a multiplication or a number that you can put as a multiplication. This is equal to the addition of the logarithm with base a in this case, okay, of p plus the logarithm with base a of the number q. Okay, this and this, okay, are the same. For example, if you have this, the logarithm with base 5 of 5 times 5, you can write this as, okay, logarithm with base 5 of the first factor, 5, plus the logarithm with base 5 of the second factor, that is 5. Okay, so this is 1, this is 1. We can calculate this. 1 plus 1 is 2. Okay, if you do this directly, okay, the solution, the result is the exponent, so it's 2, it's the same, okay? Second property. Okay, the division. So if you have a fraction, a division, okay, of p over q, you can transform this into a subtraction of logarithms, okay? So the order is logarithm of p with base a minus logarithm with base a of q. So this is the order. Start with the numerator minus the logarithm of the denominator, okay? Not the opposite thing, okay? Not the other way around. So this is the second property. If you have this logarithm of, let me see, logarithm of 1 over 10, this is a 10, okay, you see that there is no base, but when there is no base, it's 10, okay, it's 10. So we can write this as logarithm of 1 minus logarithm of 10. Okay, the logarithm of 1, we haven't seen this. When you have the logarithm of 1, this is always 0, okay, and the logarithm of 10 is 1. So 0 minus 1 is minus 1. Do you understand this? Okay. The third property, when you have the logarithm of a power. Okay. So when you have a power, you can put the exponent down, multiplying the logarithm. Okay, like this. Okay, so an exponent, okay, moves down, multiplying the logarithm. For example, logarithm with base 5 of 5 to the power of 3. You can put down the exponent, logarithm of 5 with base 5. So this is 3 times logarithm of 5 with base 5 is 1. So this is basically 3. Okay. And the last property that we are going to see now is the logarithm of a root. Okay. So this is for any root. Okay. So we can write this as a power, as you know, okay? So p to the power of, in this case, the p has exponent 1, so 1 over n. So this is equal to, okay, this is a power, so we can move the exponent down as a multiplication, as a product. So 1 over n times log with base a of p. Okay, or you can write this as this way, the logarithm over or divided by n. Okay, this and this is the same. Okay, so now we are going to see a typical exercise that you can have in the exam. Okay, so write these operations as a single logarithm. So, for example, you have logarithm of 5 plus logarithm of 6 minus logarithm of 2. Okay, the goal of this exercise is not to calculate the logarithms, because to calculate the logarithms, the bases are 10, so these numbers are not going to be exact, so we have to use the calculator. But the goal of this exercise is to write this as a single logarithm. So in first place, we have an addition, so we can transform, we're going to put brackets, okay? We can transform this addition into a multiplication, okay? So this addition is transformed into a multiplication. And finally, this subtraction can be transformed into a division. Oops, sorry, I made a mistake. Okay, so in the denominator 2. So this is the same as 5 times 6 is 30, 30 over 2 is 15. Okay, so this logarithm is the same as this. Okay, if you don't believe me, try to calculate this with your calculator, then calculate this, and you will see that it's the same. Okay, another example can be 1 over 2 times logarithm of x plus 1/3 logarithm of y. Okay, when you have multiplications, you can write this as powers. So logarithm of x to the power of 1/2, sorry, plus logarithm of y to the power of 1/3. Okay. Now we have an addition, so we can transform this into a multiplication. So we have x to the power of 1/2 times y to the power of 1/3. Okay. So, well, to finish, you can write this as radicals. Okay, remember that this is x, okay, the square root of x, and this is the third root of y. Okay, so you can write this as powers, or you can write this as radicals. Okay, so that's all. Thank you. Bye bye.